we are now looking at section 4.5b. In section 4.5a, we solved exponential equations. In this section part, we will solve the logarithmic equation, but the basic logarithmic equation in which we have only one log term. Now, what is a logarithmic equation? It is an equation in which there is logarithm of a variable. So you have a variable term. We are taking log of a term, expression which has variables in it. Okay, so guidelines for solving logarithmic equation start the same way as we do for the exponential equation. So isolate the logarithmic term first, and remember, we are talking about the logarithmic equation in which we have one logarithmic term. So when you isolate it, you will see that you have that log term, and then on the other side you have number. Now, a very important thing is, by the way, so once you have isolated it, then the next step is to convert it into exponential form and try to solve for the variable. So now an important thing about logarithmic equations is that we must check the answer, because not every answer is going to be your solution, specifically in equations in which we have more than one log term. Okay, so let's look at this first example. It says log of x minus 4 equals 3. Now this is already isolated. Log term is isolated here. So we can jump and go to the exponential form. So which means, what is the base here? So the base is 10, because no base means, no base with the log means the base is 10. So if I convert it into exponential form, I get 10 to the 3 equals x minus 4. And then what is 10 to the 3? It's 1000. I can also write it like x minus 4 is equal to 1000. And then x will be equal to, when we add 4 to both sides, 1004. Now we can check. So always check in the original equation or the given equation. So we have log 1000 minus 4, 1004 minus 4, 1004 minus 4 is equal to 3. Now we check if it is correct. So it looks like it is correct, right? Because we have log of 1000 equals 3. So what is the next step? Or how do I show now that these are equal? Well, you have tried to write this as power of 10. Why 10? Because the base is 10 here. So log of 10 to the third. So 3 can come out, and we are left with log of 10. 3 and log of 10 is 1, so I get 3 equals 3. So yes, this is the correct answer. Therefore, now another way to do it is, sometimes students do this, that we raise this equation kind of to the power of 10. So 10 on this side and 10 on this side. Okay. Now since the powers are, this thing is equal to this thing, so if I am raising 10 to the power log x minus 4, it will be the same as if I rose the 10 to the third power. So this way, what is the next step? Well, by the property of logarithm, this will give you just x minus 4, and then on the right hand side you have 1000. So you see, we have the same thing that we have here. So you can either do it that way or convert to exponential form directly. Looking at the next equation, so this is not isolated, so first we have to isolate. So what would we do? In this case, we subtract 3. So our basic algebra, so subtracting 3 will give me 2 on the right hand side. Now again I can convert to a exponential form, or we can raise to 2. Raise this equation to the power of 2. Why 2? Because the base of the log is 2. So whatever the base of the log is, that's what you need. So sometimes people do it this way. They will just put a 2 here and a 2 here, kind of meaning this is to this 2 is to this power, the same thing as this 2 is to that 2 power, which is looking weird, but people want you to understand it like that. Anyhow, so this is what 2 and 2, if that looks like a power high. But so the left hand side will give you x square minus x minus 2, and the right hand gives you 2 square, which is 4. So if I did the exponential form, I'll get the same equation. So what do I do now? This is a quadratic equation, so we have to get everything on one side, get 0 on the other side. Now factor. So factoring should be the first thing that should come to mind when you see a quadratic equation. And if factoring doesn't work, then try quadratic formula or completing squares. Okay, so here I get x minus 3 and x plus 2 as our factors. So setting each factor equal to 0 gives me x equal to 3 or x is equal to negative 2. Now I will check one by one. So first I check x is equal to 3. Now when we check, always remember to plug in the original equation. So the original equation is given here. I plug in 3 plus log of, so inside 3 square means 9 minus 3 minus 2, and we have to set it equal to 5. Okay, so what do I get? So base is 2, log base 2 plus log base 2 of, so what I get from here is 4, but log 4 base 2 is 2, so which is correct, right? Because we are getting 5 is equal to 5. Now check the other one. So we have 3 plus log base 2 of, so we will plug in the 2. So minus 2 squared gives me 4, minus negative 2 will give me plus 4, plus 2, right? Not 4, plus 2, and then we have negative 2 and equal to 5. So you see this is also giving us the same result as the previous one, so it means it will be correct. Therefore x is equal to 3 and x is equal to negative 2. These are both solutions of this equation. Okay, now you got the idea. I would like you guys to do these next two parts. Then I'll see you in few minutes. You may pause the video and try doing these problems, and then I'll come back and we will discuss the solution. Okay, I hope you guys were able to solve the two equations. So let's look at the solution. So ln of 2 plus x is equal to 1. So convert to exponential form. What is the base here? The base is e. So you can write 2 plus x equals e raised to the power of 1, which is just e. So we get x is equal to e minus 2. And you leave the answer as it is, not take a calculator and approximate, because this is how we want the solution in the exact form. Okay, check the answer. Easy checking. You can see ln of e is 1. That is something you have to remember. Going to the next one. This is again not in isolated form. So we have to isolate the log term. So first we can, remember the algebraic techniques. So the first thing you have to do is subtract the 2. That will give you negative 3 log base 5 of 20 minus x square equals negative 3. Because then you do negative 2, negative 2. So you'll get negative 3 on the right hand side. So we have negative 3 here being multiplied. So what we do next is divide by negative 3 both sides. And we end up getting this equation. What does that mean now? Convert to exponential form. So 5 raised to 1 equals 20 minus x square. So simplify. We get x square equal to 15. So that x will be plus minus square root of 15. We now check. So I checked x is equal to square root of 15 here. Plugging in the original. It's 2 minus 3 log base 5 of 20 minus square of square root of 15, which will give us just 15. And then 20 minus 15 is 5. So we end up getting 2 minus 3 log base 5 of 5 is equal to negative 1. Now what is log of 5 base 5? That is 1. So we get 2 minus 3 is equal to negative 1, which is correct. Same way we do the x to the negative 15, and we see that we get the same result. So both are solutions. Okay, so this is how you do the simple logarithmic equation. Now we will see some complex logarithmic equations.